Hello, I'm Anna Mackay, and tonight we're looking at the laws of logarithms. So the main rules that we have are, if you have a log where it's two numbers or things multiplied together, then you can split the log. That's equal to log of A add log of B. One way you might remember it is with the index laws, that if it was sort of like the same base, so they're being multiplied together, you would add the powers. So that connection between a multiply and an add, same idea here in some ways. You can't see the multiply because they're next to each other, so that turns into an add. And the subtract log law is if you have one log out the front and something divided by something, you can split that log, and it's the equivalent of log of A subtract log of B. So you might remember that divide line looks a bit like a subtract line, and that's how you get this law. And this is only the case if the bases of the logs are the same. So if they look like this, it's log of base 10. But occasionally you might have log of base 2 and base 5, then that rule doesn't apply. And the other rule is if you have log of a number to the power of something, that power can be brought down out the front, and the answers to those are equivalent. Doing some examples here. At the top, I've written those rules that we had on the previous slide, and an extra rule over here that we've done in a previous video. So part A, we have a log of 5 adding on a log of 3. So that matches the first rule that we've got there. So the answer to that is a single log of 5 multiplied by 3, and that's equal to log of 15. You can always check this in your calculator by typing in log 15 as well as log 5 plus log 3 and see if they're the same. Second one here, there's a subtract, so you're heading towards the divide rule, and notice that they're the same base of base 3, so that's equal to log of base 3 of 24 divided by 8, which is equivalent to log of base 3 to the power, well, is equal to 3. And we can simplify that even more actually. What you might notice here is it's the base 3, and then the same base number is 3 here. And as we know, anything to the power of 1 is itself, and then that matches that rule at the top right hand corner. So the answer to that is 1. Again, you could chuck B into your calculator and check that that whole thing equals 1. And part C, now you might be saying to yourself, okay, well, she's told me about this subtract rule, can turn them into a divide, but I don't have a log here. I've got log base 2 of 5 and 1. Well, is there a way that you can turn that 1 into log of base 2? So again, using this rule in the top right hand corner, log of base 2, and then if we put the 2 there, would be equal to 1 as it's 2 to the power of 1. And so now they both have log of base 2, and so now we can use the rule which is 5 divided by 2. Some more examples. The first one here, we'll use the third rule, the purple one, where there's 2 at the front, we can actually write as the power of 7. So the first step is log of 7 to the power of 2, and subtracting off log of 2 to the power of 3. And now that they are the same base of logs and it's a subtract, we can divide the 2. I'm just going to add in one extra step where I simplify these first though. 7 squared and 2 to the power of 3 is 8, and now we have log of 49 divided by 8. You might ask, do I leave it as a fraction or do I turn it into a decimal? Either is fine. Tend to keep them as fractions as long as possible, because then they maintain their exactness. If it was an irrational number or a recurring number that didn't terminate, then you lose some of the exact answer there. So keep it as a fraction if you can. Part B here, we need 2 logs. 3 currently isn't in the form of a log, so we need to manipulate that slightly. So we're going to write that 3 as log, base 10 technically, of 10 to the power of 3. And that whole thing would be equal to 3 on its own. Now, bringing them down to be 1 log each, so using the purple rule again, 3 to the power of 2 is equivalent to log of, well, this time around I'm going to write 1000. And now it's an addition rule, so I'm going to multiply the 3 squared, which is 9, multiplying that with 1000 to get our answer of log of 9000. Again, you can check that on your calculator. This last one here, log of 8 over log of 4. This is where I do encourage you to use your calculator. Check what that answer is to know what you're heading towards. A really classic error that people see is, oh, okay, they're being divided, or there's a divide law with logs, and so I turn them into a subtract. So the classic error that we get is you take log 8 and subtract off log of 4. If you do that, here's your answer, and you can see that they don't match. So that divide law of logs only applies when there's a single log word, not two logs. So how do we solve this? Let's manipulate that log of 8 first to be 2 to the power of 3, and log of 4 is 2 to the power of 2. Using that power law where you can bring it down out the front, we now have 3 log 2 and 2 log 2. And now you're not even actually going to use that subtract divide law. You're going to cancel out log of 2. You can check that on your calculator. Log of 2 is a number. So you're just cancelling out numbers from the numerator and the denominator. So the answer is 3.5. And as we can see from our calculator work over here, we got to 1.5. And our last two are show that type questions. So we have to take the left-hand side and turn it into the right-hand side. Let's manipulate that. That 9, you might think, okay, 3 squared, let's play around with that for a bit. So it's log of 3 to the power of negative 2. Now when you see a power with logs, you can bring that down out the front. So we've got negative 2 log 3 and that now equals the right hand side. Two ways to do that are you could say equals right hand side, or sometimes for a show we draw this, well, sideways hashtag if you like, an octothorpe, and that implies I've shown what I needed to show. And the second one, the left hand side, is log of 500. And you might be thinking to yourself, I can see the right hand side has a split log, which means perhaps we've used the divide rule because you can see the subtract there. Well, that means I have to get 500 as something over something. So it's two numbers that divide to give 500. Well, there could be lots of numbers that would be the case for. But some of the keys here might be the 3 and the 2. When you split that log later, the denominator becomes the one on the right hand side. So that log of 2 might give you the clue that the denominator is 2. And so you ask yourself, well, what divided by 2 gives 500? It's 1,000. Now let's split that log and see what we get. Log of 1,000 subtract log of 2. We're getting close. We need to rewrite log of 1,000 as 10 to the power of 3. And then the power rule says you can bring it down out the front. Well, I did say you can bring it down out the front, which technically leaves you with log of 10, which is 1. Or you can just use the rule that log of base 10, and then there's the base 10 here, is equal to that power number. So it's equal to 3, subtract log 2, and we've completed the show that, so we can put that symbol there. Okay, subscribe to the channel if you haven't already, and join me for natural logarithms. Thank you.